Good day everyone! Welcome back to our next part of General Mathematics. Before we begin, let me introduce myself. I am Engineer Adrian Miguel S. Omengan. I am the third placer in the recently concluded Electronics Engineer and Electronics Technician Licensure Examination. I also graduated as magna cum laude from the Polytechnic University of the Philippines. By now, we are done with Introduction to Functions, Rational Functions, Inverse Functions, and Exponential Functions. Now, let's go to Logarithmic Functions. Welcome to Logarithmic Functions, LBV Gmath 1-5.1. In this topic, our most essential learning competency represents real-life situations using logarithmic functions. The topics covered in this video are definition of logarithmic function, real-life application of logarithmic function. For our learning objectives, by the end of this video, we want to know what is a logarithmic function, and we want to know the real-life application of logarithmic function. Let us now discuss what is a logarithmic function. The logarithmic function is defined as the inverse of the exponential function. In our previous video, we discussed that exponential function is represented like this. To transform it to logarithmic function, it will be represented like this. Log of x to the base a equals b, where a represents the base, b represents the argument or the power, and x represents the logarithm. For example, we have 2 cubed equals 8. It will become log of 8 to the base 2 equals 3. So 2, which is the base here, will become the subscript. Our exponent will become the answer, and the answer in our exponential function will be the logarithm. This representation of logarithmic function is read as logarithm or log of x to the base a is b. Let's now proceed to common logarithm. Common logarithm is the logarithm with base 10. It is denoted by omitting the base. From our previous slide, we know that logarithms can take any base. But for this example, our base is 10. Common logarithm is represented like this. So instead of writing logarithm of x to the base 10, we can simply write it as logarithm of x. Again, when the base or the subscript of the logarithm is not indicated, means it is 10 or a common logarithm. Also, common logarithm is also known as Briggshian logarithm. Another commonly used logarithm is the natural logarithm. Logarithm with base of e is called natural logarithm. It is denoted by ln of x equals log of x to the base e. ln is the same as logarithm with base e. Here is a real-life example. One application of logarithmic function is the Richter scale. Richter scale is a base 10 logarithmic scale which assigns magnitude number to quantify the energy released by an earthquake in reference to an arbitrary minor amplitude. Seismometer or seismograph is a device that records earthquake. We know that the Earth's outermost layer is continuously moving, thus our instrument can detect minor movement corresponding to small amplitude. When we say amplitude, that is the height of the produced wave. However, during an earthquake, a seismic wave is produced that travels through the Earth's layer which our instrument can also detect. The higher amplitude of the seismic wave means that the earthquake is more powerful. For example, a magnitude 3 earthquake is a minor earthquake that is felt by human with some noticeable shaking of indoor objects. Let's say that magnitude 0 produces an amplitude x. Then, magnitude 3 produces an amplitude 10 raised to 3 times or 1000 times higher than magnitude 0. Therefore, magnitude 4 is 10 times higher than magnitude 3, and that is 10,000 times. And magnitude 5 is 10 times higher than magnitude 4, and that is 100,000 times. However, the difference between the scales are in the power of 10, thus to reduce it to a smaller scale, they use logarithm. So instead of 1 to 100,000 times, the scale becomes 0 to 5 only. Let's try to answer some problems. Problem number 1. Determine which of the following is a logarithmic function. A. F of x equals log of 2 to the base 3. B. Y equals cosine xy. C. F of x equals e raised to 2x plus 1. And letter D. Y equals 2x over 2y. Obviously, letter B is a trigonometric function because of the cosine. Letter C is the exponential function. Letter D is a rational function because of the division sign. And obviously, letter A is the logarithmic function with base 3. For problem number 2, determine which of the following is a logarithmic function. A. F of x equals e raised to x plus 1. B. F of x equals ln of x squared. C. F of x equals 2x cubed plus 1 all over 3x raised to 7. Letter D. Y equals cosine 3x. Letter A is an exponential function. Letter C is due to the division sign is a rational function. Letter D is a trigonometric function. And lastly, letter B is our logarithmic function. Remember that ln is a logarithmic function with base e. Problem number 3. Determine which of the following is a logarithmic function. Letter A, f of x equals cosine 2x. Letter B, f of x equals 3x plus 2. Letter C, f of x equals cosecant 2x plus 5. And letter D, f of x equals log of 2x plus 1 to the base 10. Letter A is a trigonometric function, again because of the cosine. Letter B is a linear function. Letter C is also a trigonometric function. And letter D is our logarithmic function with base 10. Problem number 4. Change the given exponential equation into logarithmic equation. 5 squared equals 25. Let's remember that exponential function is represented like this, just like in the given. A raised to b equals x. And we can transform it to this form. Logarithm of x to the base a equals b. So from 5 squared equals 25, it will become log of 25 to the base 5 equals 2. Problem number 5. Change the given exponential equation into logarithmic equation 3 raised to x equals 2. Again, let's remember that exponential function is represented like this, just like in the given. And we can transform it to this form, logarithm of x to the base a equals b. So from 3 raised to x equals 2, it will become logarithm of 2 to the base 3 equals x. Problem number 6. Change the given exponential equation into logarithmic equation. 4 raised to 2x minus 1 equals 64. Let's remember that exponential function is represented like this, a raised to b equals x, just like in the given. And we can transform it to this form, logarithm of x to the base a equals b. So from 4 raised to 2x minus 1 equals 64, it will become logarithm of 64 to the base 4 equals 2x minus 1. Problem number 7. Which of the following statements concerning logarithmic functions is or are true? Statement number 1. Logarithmic function is a one-to-one function. Statement number 2. Logarithmic function is the inverse of an exponential function. In our previous slides, we defined that logarithmic function is basically the inverse of exponential function. Therefore, statement 2 is correct. Since exponential function is a one-to-one function and its inverse, the logarithmic function, is also a one-to-one function. Therefore, statement 1 is also correct. Problem number 8. The exponential function 3 raised to y equals x, if will be converted to its equivalent logarithmic expression, the base on the resulting equation will be which of the following? So again, from exponential, which is a raised to b equals x, it will become logarithm log of x to the base a equals b. So transforming 3 raised to y equals x, it will become logarithm of x to the base 3 equals y. So based on the question, we are asked to find the base. So obviously, that is the subscript, which is 3. And that's the end of our lecture. What we learned, what is a logarithmic function, and the common logarithm and natural logarithm, and the real-life applications of logarithmic function. In our next video, we will learn logarithmic functions, equations and inequalities, laws of logarithms, and solve problems involving them. For supplementary problems, you may refer to Queck's book General Mathematics, Chapter 3.